Yeah, I just wanted to take a moment to take a look at a quick, fun fact about rationalizing denominators. We take a look at the Parthenon. So this is a model of what the Parthenon would have looked like, and something mathematical comes out of this image. So something called a golden rectangle. So there's a ratio of width to height, and it's expressed as 2 over root 5 minus 1. So the Parthenon at Athens fits into a golden rectangle once that triangular pediment is at the top. So what happens is the number that comes out of this after we rationalize is called phi. And if you've never heard of phi, it's just like it's a transcendental number, which pi fits into be a transcendental number. And if you've heard of Euler's number, that's also a transcendental number. But these are numbers that are kind of special to mathematics. So I've given you 2 links to take a look at. The first one's golden ratio, gives you a little information in Wikipedia about reading a little bit more about it. And then the second one is Numberphile, and they go through some nice examples and show how it's related to some things, more than just one, and it's more than just seeing what the mathematics does, but how it's related. So if we take this and we take 2 over root 5 minus root 1, well, we know how to rationalize the denominator, and we're just going to do that. So we're going to take a form of 1 in this process, and when we do that, we get 2 root 5 on the top plus 2. Remember, we have to distribute. And then on the bottom, when that occurs, we get root 25 minus 1. And as we know, that middle 2 terms are going to cancel each other out. That's one of the big ideas behind rationalizing the denominator that I want you to remember. But you should see that. You can see that and prove that to yourself by doing the FOIL method or the area model, Punnett square. You see the mathematics. It's not really the mathematics. It's more like the calculation. So when I take this, I get 2 root 5 on top still, plus 2, all over, and then 5 minus 1. And we keep going. And that's all over 4. So it looks like it's done. We've rationalized the denominator, but another thing you can see is 4, 2, and this 2. So they all share a factor. So we can take it down a little further. So we can say 1 root 5, or just root 5. We have to do the top as well. So it does go into the other term. That's going to be 1 over 2. Now this ratio is the golden ratio. So this is the golden ratio. And that comes out to about 1.61. You can look at the numbers, look it up and see what the numbers actually are, but we'll notice that is that's phi. So just like pi, this number has its own Greek letter, phi. I just thought it'd be of interest to take a look at how it applies, and I would encourage you to take a look at both of these links as well.